Welcome, everyone. I have muted everybody for now. I'm your Zoom facilitator for panel A. And I'm just going to, before we get started, I'm just going to quickly introduce the moderator for this session, who is Joe Butchers. Please correct me if I have pronounced your name wrong. So yeah, so Mr. Butchers is a researcher based at the University of Bristol. He recently completed a PhD focused on understanding the sustainability and reliability of micro hydropower plants in Nepal. The research explored the project process, turbine manufacture, and the operation of plants. In relation to operation, the research explored the connection of technical, social, and economic factors that affect how a hydropower plant performs. The reason on turbine manufacture focused on exploring the opportunity to develop a turbo turbine design. Currently, he's continuing to collaborate with the People, Energy, and Environment Development Association and Nepal Yatrashala Energy on the development of a 30-kilowatt turbo turbine. In the longer term, he plans to make the turbine design available freely online. So I'll pass on the mic now to Joe.
Hello to everyone, and welcome to our session today, where the focus will be on technical reliability and capacity building. And as highlighted by Dipti, technical reliability forms a foundational aspect of the SEED approach, enabling us to develop sustainable and socio-economically impactful hydropower projects. Without technical reliability, it's very difficult to deliver projects which enable us to use productive end uses. And so where mini and micro hydropower projects are used, building local capacity, manufacturing turbines locally, and using technical standards all enable us to achieve technical reliability. There are several benefits of doing this locally. It means that when there are issues with projects, if there is local capacity, we can quickly troubleshoot the problem and also address the problems at a lower cost. Furthermore, innovation that takes place locally can be focused on the specific challenges of the local area. To add to this, when local capacity is improved, it allows us to create jobs and improve the skills that are held locally. So in today's session, we will hear from practitioners who have established centers of local manufacturing. And we will learn about their latest developments. We also hope in this panel to develop the conversation around technical standards and job creation. So I will now introduce the panelists. Oh, and I also, as we move through the session, if anyone has any questions for the panelists or general questions for a wider Q&A, please do add them into the chat, and hopefully we can address some of those. Okay, so Alice Lasimbang is the head of management at Tonybung, the Center for Renewable and Appropriate Technology. Alice has been the head of management at Tonybung since 2019. She was previously a civil servant for 16 years before joining Tonybung in 2017 as a coordinator for community engagement and socio-economic development. Tonybung is a social enterprise from Penang, Sabah, Malaysia, that brings cost-effective resource management solutions to underserved rural indigenous communities in Malaysia. Can I have the next slide, please? Our second panelist is Benazir Bacala, who is a supervisor at CREATech. Benazir joined CIBAT in 2018 and was inspired by the organization's mission and vision in promoting and developing renewable energy systems in the Philippines. She works under renewable energy programs of CIBAT, where she's part of the team responsible in doing technical surveys and write-ups for possible projects. With her dedication and commitment to her job, she was then given a higher role in managing and supervising the manufacturing and designing of components for MHPs and other post-harvest machinery. Although she is young and new to the organization, she is motivated to build more reliable and appropriate technology for the disadvantaged communities in her country and to take part in saving nature. Next slide, please. Our third panelist is younger Imchen, who is a project coordinator at Nagaland Empowerment of People through Energy Development, NEPeD. Younger is working as a project coordinator for NEPeD. At present, he's based at the Center of Excellence for Renewable Energy Studies in Dimapur and involved in R&D as well as installation of renewable energy technologies. Looking forward, he would like to work in developing hydro projects on a larger scale, as well as developing and installing other rural innovations and technologies that are eco-friendly and practical. Mr. Imchen has a background in mechanical engineering, and his initial posting was with the Nagaland State Mechanical Department. He then joined Nagaland Tool Room and Training Center as a process planner, where he was involved in training students as well as at R&D for various projects. He was then assigned to NEPeD and was involved in developing the indigenous hydrogen, a pico hydro unit, and installing units within and outside of the state. Outside of work, he loves listening to all kinds of music and is an avid biker. His favorite pastime would be tinkering around with various DIY projects. Next slide, please. Our final panelist is Gerhard Fischer, who is a freelance consultant and director at the Hydro Competence Center, HYCOM. Gerhard Fischer has a diploma in mechanical engineering from the University of Stuttgart. He completed postgraduate studies as a welding engineer and participated in a postgraduate study on energy management in developing countries at the Technical University of Berlin. He looks back upon more than 35 years of professional experience in the development of hydropower. He has specialized in technology transfer, concentrated on turbine design and manufacturing, and has working experience in 27 countries so far. He worked 6 years as a researcher at the University of Stuttgart in Germany in the hydraulic laboratory for the Institute of Hydraulic Machines and Fluid Dynamics. During this time, he was in charge of construction and installing the hydraulic laboratory and research on simple turbine designs. He worked 5 years in Switzerland as a project engineer for hydropower projects and trainings in a small engineering company. From 95 to 97, he was an engineer with SCAP in St. Gallen, Switzerland. And then from 97 to 2013, he worked for NTech on several assignments covering all aspects of hydropower development in Switzerland, South America, Africa, and Asia. From 2005 until March 2013, he was director of HPNET Indonesia, a consulting and engineering company active in the micro hydropower sector in Bandung, Indonesia. From 2013 until March 2016, he was advisor for ASEAN HYCOM in Bandung, Indonesia. This position as integrated expert was supported by CIM/GIZ. And since March 2016, he has been a freelance consultant and director of HPNET Indonesia. So those are our panelists today. Thank you all of them for speaking. I'll remind you that please do add any questions into the chat, and we will now move on to our first presentation from Alice.
Good afternoon, everybody. Thank you, Joe, for the introduction. Hello, everyone. My name is Alice, and I am from Tonibong. So I've been with Tonibong for a few years now, but not long. So next slide. My presentation today is about social enterprise in CREATech. So before that, I would like to introduce Tonibong. So Tonibong is also known as Tobinay Ning Kokoton Kaburan Kampong. That one is in Kadazan. So in English, it means Friends for Village Development. So we are indigenous people organization based in Sabah, Malaysia. So, and experience on small scale renewable energy in microhydro, solar PV, solar thermal, and also biogas. So we also have a center called CREATech, Center for Renewable Energy and Appropriate Technology, where we combine design and fabrication, research and development, training course on RE, entrepreneurship, and also management for MHP system. Next. This the picture is shown. This is our center CREATech in Penampang, Sabah, where we give training to the local operators, training also on feasibility studies, and also manufacturing turbines. Next. What I want to talk about today is the CREATech social enterprise model. So since 2019, Tonibong have changed from NGOs to social enterprise. So in our social enterprise model, we have provide service to the community, especially in the management of the microhydro system, billing and management, service, maintenance, operators, where we employ local from the local communities, social economy for the communities, and also e-commerce. Next. So these are Tonibong social enterprise model. But after the system, usually in certain project, after the system is installed and it's been working on a few years, when it breaks down, we usually have this assessment to the system, when we make a proposal to the community. And then after that, we will do the meeting with the community regarding our proposal to manage the system. If the community agreed to it, and we will set up an admin and account for the system. After that, we will set up tariff rates, and then operators retraining, and last but not least, managing the system, where we will do the billing, maintenance, and collection. Next. So the first service that we have done is in Ulupapar microhydro system. In Ulupapar, situated in Penampang, is not very far from Kota Kinabalu. So there are 6 microhydro systems in this area. There are Kampung MHP Kampung Tirian, MHP Kobulu, MHP Kampung Tiku, MHP Kampung Longkogungan, MHP Kalanggaan, and MHP Pongobonon. The MHP stands for Micro Hydro Project. So in this picture, we see Adrian here is giving some explanation to the system in Kampung Tiku, and below is the system in Kampung Kalanggaan, which is still working up until now. Next. So these are the map of Sabah. So this is where the MHP Tirian and Buayan are located. Actually, all the 6 systems is all around in this area. Next. So a little bit background in the Kampung Tirian. It is located near Crocker Range and installed in 2004. So the project period is 2001 until 2004 and funded by Ecology. It is 5 kilowatt project for 25 households. At first, when the system is installed, it was managed by the local village, Tinipot. And after that, the system only lasts for a few years before it breaks down. And then after that, in 2017, we get some fund from also from psychology to develop to revive again the system. But unfortunately, in 2009, the system break down again due to there's a lack of maintenance and lack of fund to maintain the system. So in 2020, we decided to revive again the project, and this time Tony Bung have decided to take over the management in order to revive the system. Up until now, the system is still working. Next. This one is about the micro hydro project in Kampung Buayan. So this system is installed in 2000. The first one is in 2009. The period project was from 2008 until 2010. The funder was UNDP, and it's a 10 kilowatt for 22 households. So after they build the system, a lot of people from town are going back to the village, which is very positive from what the micro hydro have installed. But unfortunately, in 2018, before the system breakdown due to lack of fund to maintain the system. And also the owner of the powerhouse decided to take back their land. So we have to move to another place for the project. So in 2018, it was funded by Shell. So we built another micro hydro project for 20 kilowatt for 56 households. They are using digital meters and for a tariff about 1 ringgit per kilowatt. Unfortunately, 1 year after the system is working, it is breakdown due to one is a lack of fund for maintenance, and the community can seems to organize themselves to do maintenance, communal cleanup every time there's flood or anything that happen. Next. So this one is in MHP Kampung Tiko. So far, these are the best management in Ulu Papar up until from 2014 until now, the system is still working. It is 5 kilowatt system to cater 15 households. And that's the only major system without major breakdown. It is due to maybe one of the reason is being the leadership, because of the leadership of that, the leader can organize the people to work together to clean up the system, and they all are working together to pay for the tariff for the maintenance system. And also it was used to have a prepaid card system, but unfortunately due to the lack of IT skill in the village, we have to change the system, the payment system, into analog system. Next. This one is in the MHP Longkogungan. So far, the system is the most challenge we have so far, especially in terms of logistic, because it can only be accessed by walking from Batu 32, going downhill about 8 hours, or by walking through a Crocker Range Forest Reserve, or by a helicopter. So by helicopter, you can reach there about 15 minutes. If you have money, you can pay about 15,000 to go there by helicopter. That's it. The system was installed in 2016, and it's 5 kilowatt for 23 households. The system was breakdown in 2017 due to lack of maintenance and also lack of fund to pay for the operators. Next. So Tony Bung decided to give our service for system management. Why? So it is because of our social responsibility to the funder, Shell, UNDP, Asia Foundation, and Psychology, because we promised the funder that we will give a working system to the village to provide electricity. So if the funder sees that the system is not working, that means we have failed in our responsibility. And the next will be the poor management of the community fund. So this usually, since the the tariff collection is the only fund that have in the village, it is sometimes misused for other things other than the maintenance of the micro hydro system. And the other thing is the lack of leadership. So the lack of leadership will brings to the community unable to organize themselves to do the maintenance of the system. And the operators' lack of training is also one of the reasons, because usually when the system is installed, we will give training to the operators. But when the operators move out from the village, or they are being too old to do some maintenance, that's when the system will go down. And also, we wanted to improve the renewable energy, especially in micro hydro in Malaysia. So as we can see the picture here, this is done by other organization. It's an example of how they put their transmission line. They just put it on a tree, which is very dangerous to if any of the village touch it. And you can see in the powerhouse, this is the powerhouse where the wires are hanging around. So it is the standard. We want to build a standard safety for the micro hydro system, so we can show it that micro hydro system works. Next. Next. So one of the service that we will be doing in our social enterprise is the maintenance. It is also, can we go to the previous slide? So, okay, thank you. In the maintenance, we will do the maintenance of the system, especially in turbine, pipes, transmission, but all are done by the local operator, which is the operator that we have trained. But the ELC will still be under Tony Bong's staff. We will once in a month go down to the village and check everything to make sure the system is on track. Next. Next slide, please. So in the operators training, we will train new and previous micro hydro operators from the village, and a refresher course training will be done once a year. Trained operators will be hired part-time to maintain the system. So in a way, the trained operators will be paid accordingly to the work that they've been doing. So in the picture, you see, this is a communal cleanup in Kampung Tiku, when this is post-flood that happened recently. So the community organized a communal cleanup for the Fobe. And down there, you can see the training by the staff of Tony Bong. Next slide, please. Next. So in the finance part, so we will impose an admin fee, 5% in every system, and also in maintenance system. And we also give operators allowance to every operators that doing this maintenance. And communal cleanup. This one is we give rebate on every members that join the community cleanup. Usually the rebate is cost about 15 ringgit per household. So these are the example of the electricity bill that we give to the community. So we can see there's one column that says rebate. So if the household have joined a community cleanup, they will get a rebate there. So it is one way of reducing their electricity bill. Thank you. Next. So we create a one payment system for the community. So since the pandemic COVID-19 in Malaysia, and the government have imposed a MCO in Malaysia, so the community cannot go to sell their product. So one of the things that we do was to get a product from them. They can pay through agriculture product such as tapioca, ginger, turmeric, chili, and many more. And you can see here in the picture where the one of the villager is selling wild meat to one of the staff, and we just have a lot of product from the kampung, the village, such as tapioca, lemongrass. And we also give a rebate for those who join communal cleanup or do their own meter reading. In this meter reading, we created one WhatsApp group for each village, where each village, they will every month before 16th of every month, they will WhatsApp the pictures of their meter. So that's where we can do the meter reading. So they will get a rebate about 2 ringgit. And also, from time to time, we will do a research online survey to the community. So those who join the online research, they will receive 2 ringgit rebate on their billing. Next. So our future plan, we plan to upgrade the system on each village and also produce at least 2 experts in the system in every village. And we wanted to improve the socio-economic scheme, like we will try to produce a solar dryer or brewery in the kampung, because in the village they have a lot of free flow of water, and also in the powerhouse there are a lot of unused energy, especially that goes to the ballast. So we are thinking of doing socio-economic scheme. And also we wanted to include other areas that need help with the management system, especially in the Pensiangan area. Pensiangan is a rural area also in Sabah that also have a lot of micro hydro potential, and Tony Bung have installed a few of micro hydro solar system in that area. Last slide. So that's all for my presentation. Thank you for listening. For more information, you can contact us at this address. So that's all for my presentation today. Back to you, Joe.
Thank you very much for an interesting presentation, Alice. Really interesting to hear about different approaches to try and maintain the income for the plants. Particularly, I was interested to hear about consumers sending WhatsApp pictures of their meter readings. It's not something that I've seen myself in Nepal. We'll now move on to Benazir's presentation. So Aisha, if you can load the next set of slides, please.
Okay, thank you. So once again, good afternoon. I'm Benazir Bacala, the CREATech Supervisor of CBAT. I'm also with Mr. Shen Maglente, our Deputy Director, and Ms. Jade Angalao, our RA Program Coordinator, who will be also presenting later. So my presentation is about CBATs in developing reliable MHP technology. Next slide, please. So my organization is CBAT, which stands for Sibol ng Agham at Teknolohiya, or in English, it's Wellspring of Science and Technology. Next slide, please. So just a short background, what is CBAT is? CBAT is a non-governmental and non-profit organization established since 1984. It's a recognized innovator and developer of appropriate technology in the rural off-grid areas in the Philippines. The core programs of SIBAT are community-based renewable energy, community-based water resource development, and community-based sustainable agriculture. Next slide, please. So in adhering to promote appropriate technology, CBAT has the following principle. First, it is responsive to the needs of the community. We design and fabricate according to their needs. Second, generate real benefits, promote social justice and equitability among disadvantaged sectors and population in the country. So the system as benefits has lightning and power to support agriculture production and opportunity and to own and manage the system. Next, it's based on people's participation of developing local capacities and overall technological self-reliance, which means the people participates in designing the system, operating and sustaining the system on the context of community-based framework. And lastly, it strictly observes the basic regard for environmental conservation and protection, particularly in watershed protection and conservation necessary for the MHP systems and water supplies for their domestic and irrigation usage. Next slide, please. The Renewable Energy Program has discussed and planned out by CBAT Network as early as 1994, and implementation went full blast in 1997. The CBAT staff were then sent to abroad in Nepal and Sri Lanka to train and study the fabrication of MHP system. Then CBAT developed its first generation of MHP system. Its main purpose is for household lighting only. Although the fabrication of these MHPs was not highly polished, they performed well. And also in some community-owned CBRES, they were able to build productive structures such as rice milling, to which they utilized the mechanical power of the MHP. Next slide, please. Since it's the first generation of MHP, some of our components were not locally available, so we have to import, particularly these ELCs. These ERCs are still installed in some of our areas and they're still working. However, they're very expensive and hard to get parts replacement. Given all these difficulties in availability and importation and the increasing demand for troubleshooting and parts replacements of MHPs, CBAT decided to establish CREATech. Next slide, please. So the CREATech, or the Center for Renewable Energy and Appropriate Technology, was established in 2014. It is a one-stop shop for potential RA proponents, hub for advocates and students of community-based renewable energy. It aims to provide trainings, research, and manufacturing services to CBRES. We ensure to secure all the basic equipment and facilities to perform its tasks, especially in the fabrication and conducting trainings. With all of this, CBAT has the capacity to build prototypes and to support field implementation and technological requirement of CBRES. Next slide, please. So here are some of the activities that the CREATech have been working on. In the first photo, you will see that this is the wind system donated by Anakata. We just assembled it and still it's currently under progress. The second and the third photos is the fabrication of our cross-flow turbines for our ongoing projects. And the photo below is also the wind system, or the Pigot wind system. And the next one is the ram pump for our community who needs water resource development. And lastly, the Pelton turbine, which is the product of our training held in last 2019 after the HPNET training held here in CBAT. With the help of our trainer, Mr. Ajit Kumura and Udaya, and also HPNET, particularly Ms. Dipti Baghela, and all the local and international partners who have joined us in the training. However, the Pelton turbine was not yet fully installed in the area since there's safety trouble protocol and security reasons. And hopefully by the end of the year, we can do it. Next slide, please. Here are the CREATech fabrication of turbines and ELC for MHP. So these are the cross-flow T12 turbine, Pelton turbine, and ELCs. The development and manufacturing of these turbines and the development of open source electronic load controllers, or ELC, with the help and support of our former EWB volunteer, Engineer Dan Fredman, had accelerated the establishment of MHPs and to help us to build our local capacity and self-reliance in building our own system. Next slide, please. So aside from that, we also fabricate these agri-equipment tools to help in our sustainable agriculture programs. So in this first photo, we have this in the sugarcane machine. The sugarcane press, which some of the communities have obtained to process their sugarcane crops, produce muscovado sugar, sugarcane 1 and muscovado sugar. And this wheelbarrow and rotary weeder are also help in the production needs. Next slide, please. So we continue to keep in touch with the community to monitor and assess them with the technicalities and challenges they have encountered with the system. We conduct meetings and technical consultations to help them understand where the problem and what are the reasons, so they would be able also to resolve it and prevent it from happening again. Next slide, please. So one of the feedback from the communities, they said that this kind of butterfly valve was difficult to control the flow of water. So most of our MHP now have this kind of geared type of butterfly valve to control the flow of water and avoid sudden rush of water. And also so that women can operate the system. Next slide, please. So we continue to enhance our capacity through knowledge and technology sharing and mentoring from volunteers and network partners. And also we do regular meetings to discuss and build consensus design to address the problems by the communities and our system. Next slide, please. So we also conduct and attend trainings. We attend trainings to also improve our capacities and skills, and we conduct trainings to help to the community to train them and guide them, and to further enhance their capacity of the community-based renewable system organization to be self-reliant in terms of technical repair and troubleshooting. Next slide, please. So CBAT continuously partner with the international supporters, global giving, green empowerment, and of course, HPNET. And at the local, we have the local government units in areas which CBAT had established community-based renewable energy system has been very supportive and helpful. We also have the Department of Science and Technology, a government agency which consistently partners CBAT and tapping CBAT in conducting feasibility study for their prospective MHP project. And we also have the academe, the University of Rizal system, which they seek assistance from CBAT to train their students to do technical surveying. Next slide, please. So building technological robust system is a continuous work in progress of CBAT. Next slide. So that would be all. Thank you.
Thank you very much, Benazir, for your presentation. It's great to hear about the diverse range of activities that are taking place at CREATech. We just now have 5 minutes to ask a question to both Alice and Benazir. Subsequently, after the next two presentations, then we'll have a longer Q&A with all of the presenters. So please do add any questions into the chat. I would just like to put a question to both Alice and Benazir. It's really interesting to hear about some of the challenges that you have both faced in the field in relation to operation and particularly the training of local operators. And so I wanted to just ask, firstly, to Alice, what do you think is the greatest challenge faced by local operators when they're operating turbines in the field, and how can you overcome that challenge?
Hello, Joe. So one of the many challenges that I heard from the local operators will be especially the weather, because the main problem with the micro hydro system in Ulu Papar area is flood. So during the flood, it is sometimes become quite dangerous for them. But since they wanted electricity, so they will go through the jungle, because most of the system is in the jungle. So they will encounter a lot of wild animals. At the same time, in total darkness, they have to go to the system to see what is happening with the system. And also challenges from wildlife, because most of the system is in the forest reserve, especially the water catchment. So sometimes they will find a lot of snakes like python that goes through the system or inside the powerhouse. That's we don't know, somehow this wild animal attracted by the heat of the system. So it is one of those challenges. And other than that, it will be getting cooperation from the village itself, because sometimes during the season, paddy planting season, everybody is busy. So having people coming down to do a cleanup, it's not going to be easy to get people to gather. That is some of the problem that they are facing.
Thank you, Alice. Same question for you, Benazir, and perhaps if there's anything particular during the training that CREATech delivers, perhaps you could explain how that helps to overcome some of the challenges that you face over there.
For us, I think most of the challenges we face is that the turbines, sometimes the effect of the sediments that goes inside the turbines, which create the cracks on the inside the turbine, so we have to repair it. And I think because of it, it's the civil works also play a big part with that, because if you have a poor civil components, then the electromechanical components will also be affected. So during our trainings conducted, we also help them understand that they also have to clean the civil components to protect to protect the electromechanical components inside the powerhouse. Not only the electromechanical components are important, but also the civil components as well.
Thank you, Benazir. Yeah, the point that you make about civil components is something that I've really seen in Nepal when visiting from one site to another. It's common to see that perhaps sometimes the quality of the civil components it leads to the introduction of more sediment into the system, which then can damage the turbine. So it's very important that the quality is maintained on the civil components as well. So it's interesting to hear that that's also something you've experienced. So now we'll move on to our next pair of presentations.
Okay, good afternoon, everyone. Since I've been given just 12 minutes and I have a few slides, I will just quickly run through them, and they're mostly pictures, so you can look at the pictures while I explain them. And then if you have any questions, you can come back to any of the pictures during the question and answers. It's so nice to see so many old friends out here also. And my presentation would be sharing about how NEPeD functions and our way of doing things. So for those of you who are new about NEPeD, we are a team that came into being in 2006. And we have members from various backgrounds, from the agro-allied, and we have some technical members with mechanical, civil, and electrical backgrounds, as well as from geology and social sciences. Looking at our vision statement, I would like to just focus on the sustainable livelihoods, which we focus on, and driven by locally generated eco-friendly power. That brings us to our mission statement. Out here in the mission statement, our main focus is in development and creating awareness, and of course the bottom-up approach, and also the green energy utilization and its benefits for enhancing the quality of life. This brings us to our main focus, which is the hydrogen. This is a unit, a pico unit, and as you can see from the slide, on the left-hand side is our pico turbine, which is impulse, and in the center is a reaction type, and on the right-hand side is our electronic load controller. These are small portable machines, and the reaction one we are in the process of developing, but our main installation so far has been with the impulse type. For those of you who are from the technical side, the ELC is frequency based and has 4 dump load arrangements. Now, all this is possible because we have local manufacturing. Local manufacturing has helped us to lower the costs, helped us with part availability, and also replacement and repair. So with that in mind, NEPeD set up our Center of Excellence for Renewable Energy Studies, that is CERES. And CERES is not only for production, but we do conduct trainings and workshops with like-minded organizations. Notably, we had a big workshop with International Rivers, and of course, a lot of training and workshop sessions with MBDA from Malaysia. To run this center, we have a dedicated team of local technicians who are not only into the manufacturing, but they help out with the research and development. They come with us to the installation sites, and they are also trained to help spread awareness. And they are also quite passionate about their work. On the left-hand side are some pictures. These are actually, we outsource some of our work to entrepreneurs, and of course, that helps in their income also. Now, the next thing I would like to focus on is the locally available components. So we give our priority to locally available components, which, like I mentioned earlier, is cost saving, helps us with our repair, and of course, saves time. Like Augustus mentioned in the opening session, without community participation, even though this theme is on technical reliability, but the community participation is one of the main focuses of NEPeD, which has helped us in our success. So our projects are all community driven, and we make sure that we look into their viewpoints, their needs. We look at their best interests in mind, and we, before installing our projects, we do have various discussions with the communities involved. The next thing is partnership. So out here in the pictures, you can see that the communities are not only just looking on, but taking an active part as partners during the installation of our projects. Our projects also have this feature where we have training for the rural engineers. The rural engineers are those who are based and have worked with us at the sites, and they're from the community themselves. And every site we have a committee formed, and these rural engineers, they work under those committees. The other thing is we do conduct other trainings, and you can see on the bottom left that is a training we conducted for NBDA sponsored trainees who were interested to come and learn about hydrogen. The next thing is, as I mentioned earlier, involvement. Involvement of the whole community brings a sense of belonging, you know, that the project is for them. And so their involvement is very important for us. And we discourage bystanders where we are the ones working and they look on. So we encourage them to come and help us with our work and learn at the same time. And of course, awareness. Wherever we install our projects, we try to create awareness about the environmental protection, about the catchment area, and appreciation of their own resources, and encourage the indigenous values and traditions. And finally, ownership. After installing, we hand over the projects to them, and they are the owners. And of course, like I mentioned, they have to form an energy committee wherever the machines are to look after them. The next part would be, I would like to share few pictures about how we go about installing. We have our own way of installing. So beginning, we have our site survey and feasibility, where we take head and discharge measurements. We also look at the end use and the distance of the sites from the villages. We also have prior preparation because our sites are very remote, so we ensure that we pack all our equipments properly, and because we cannot come back to get things. And the other thing is we do comprehensive testing before installation. The next part would be the practicality. We make sure that you know, the sites are practical. And if you see on the top, for those who are a bit more technical, that's not the way to put a penstock. But in our case, our machines are quite small. So for us, we focus more on the practical aspects. And out here, we can see that you're using some flexible pipes as penstock. On the other hand, on the other picture, on this one, you can see that the village is in the background. So the distance is important also. This picture shows the water flowing after the hydrogen. It flows into a fishery. And finally, the ultimate thing is the end use, how it benefits them. So we keep all these things in mind during installation, the ultimate aim being for sustainable livelihood, empowerment, and the quality of life. The transmission is done with the help of the locals, and here you can see how we are installing the wires. And the other thing is you can see the village in the background. Those are the houses, and we set up a mini grid, and we ensure that the power is supplied fairly and equally to all the houses and reaches everyone. We also have on-site training when we are installing, and the picture out here down here shows one of our rural engineers explaining things to another rural engineer from another area during installation. So the rural engineers also help us in our projects. On the right side, you can see some of our own members taking training from RAMS, which was facilitated by HPNET. And we had a very good session of experience, knowledge, and idea sharing and suggestions. Finally, if funds allow, we try to upgrade our sites. So out here you can see that an old site has been upgraded, but this all depends on fund availability. Finally, we always conduct our testing and research, and this is perpetual. And we always focus on improvements, modifications, and innovations as far as possible. The final thing I would like to share is our design considerations, what we go into while designing our hydrogen. The first and foremost is the robustness. So we make sure that it's tough, it's solidly built, and it can take a lot of punishments because we take them to certain places where we cannot handle them delicately. And like the topic of the subject, it's technically reliable. The other advantage is its portability. We can take them to places where there's no roads. And on the other thing I could show you is this. This is a portable 4-way tank we just made because we didn't have time. The tank could be made later. And finally, this repair and replacement, which is very important. So if there's any problems, we are there to repair. On the left-hand side, you can see an ELC that was damaged because of negligence. Water got through it. And on the left-hand side, some components that were damaged because of a small landslide, which we brought back to repair. And there's always improvisation. So on the left-hand side, on a 4-way tank, it was the villagers' suggestion that we put up a bamboo mesh just as protection from debris. And on the right, you can see that we're using their local idea of bringing water from the source, and that is made from a tree bark. So wherever we go, we try to improvise. And finally, accessibility. We were able to install in various locations which are very difficult and challenging. And on the left-hand side is one we installed in Leh and Ladakh region of India for the army at a high altitude. And on the right side, you can see that that's an installation going on in Arunachal Pradesh. So we've installed our hydrogels from the eastern part to the westernmost part of the Himalayan range. The other important thing I would like to state is the interchangeability, because we need to have interchangeable parts. This really helps because we can take components from one to another, and even the ELC is uniform for all the pico units. And it gives us a lot of flexibility in our installations. And to end my presentation, last but not the least, but the importance of keeping it simple. So the simplicity of our project has really helped us in its success. Thank you very much.
Thank you very much, Younger. Perhaps we can give Younger a question in this time. And we did actually have a few that have appeared in the chat box. So, Younger, how does NEPeD identify the communities that you work with?
Yes, we actually do a lot of survey in our state, and we go around looking for feasible sites. But I could say it's a bit of both, because we've had communities who are in need, who have approached us and requested us to do a feasibility study. And if it's feasible, we do go and check it out. And so it's a part of identifying feasible sites as well as the requirement. So if there's a feasible site, but the requirement does not justify, then we do not. But in most of the cases, I think they are required for the rural villages, especially the ones bordering Myanmar, where life is very difficult, and just having basic electricity is so important for them. Thank you.
Thank you, Younger. And another question that's come in concerns whether these examples of successfully community-owned and managed systems, whether they affect policymakers who tend to focus on fossil fuel-based energy development. I was just, perhaps we can go back to Alice and get her thoughts on whether the government in Malaysia you feel if they're aware of the activities that you're doing, and if you have seen any effect on policy in Malaysia.
Hello, Joe. On my thoughts of getting the government into renewable energy, we have done it before. So what we do is we bring the government in. Especially the government officers, we bring them to the community involved, especially as a micro hydro practitioner. We usually bring the government to the village, let them see for themselves how the community handle the system, and at the same time, we also do a policy workshop that involve the government officer. So that's how we do it. And slowly it does have an effect where the government officer listen and they are open to suggestion. Because during that now, Tony Bung is working with a few NGOs in Malaysia and also with Green Empowerment. We are trying to convince the government to accept the policy making for renewable energy. We are doing the roadmap for renewable energy in Sabah.
Thank you, Alice. Perhaps Benazir, can you share your experiences on the same topic? Do you think that policymakers are aware of your work and whether you've seen any change?
Yes, I think so, because some of also the other government agencies are partnering with us, and they are encouraged to do also renewable energies because they think that it's very successful, especially when they go to the provinces where our projects are. So they are very encouraged to do the same also.
Thank you, Benazir. Gerhard, perhaps you can also give us some thoughts on from your experience on how things have changed in relation to policy, and perhaps give us your thoughts on whether we're heading in the right direction, or if we still need to put more pressure and more persuasion onto policymakers.
Yeah. Okay. Can you hear me? Yeah, I hope so. Yeah, policy is quite difficult because now there is a big focus on this photovoltaic and other renewable energies, which are maybe not as complex as hydropower, and easier to put projects into place. So policy also should see on the long-term availability of hydropower or the long-term effect on it. Yeah. Basically here in Indonesia, since 1 or 2 years, it's quite difficult for everybody to, also the Corona problems. So the government projects are somehow down, and politics not really focusing on hydropower anymore as a subject. Yeah. So it needs some lobby work to bring it back to mind, maybe even combining it with the effects that we can integrate the catchment area protections and environmental issues also with the hydropower. It's a niche. There are sites which are good, but it cannot be applied everywhere easily. And yeah, I think everybody is aware of that. Definitely it needs a lobbying for the politics as well, and keeping this technology in the mind of donors and supporters, and also implementers also the industry or many sites could supply very cheap energy for industry, and we have to keep this awareness alive.
Perhaps related to the policy as well, we could briefly think about standards. And going back to Alice, you mentioned safety standards in your presentation. Do you think having national level standards would be helpful in persuading policymakers that micro hydropower technology is viable alongside other alternatives?
Yeah, I think it's some kind of a condition. If you have government-supported projects, there should be also some kind of a standard followed. And it's quite difficult to make the standards not as a killer for these low outputs. We cannot fulfill so many regulations, and so it must be more pragmatic standard to be followed, which is based on good workmanship, and not following these international standards, which are for our purpose below 1 megawatt is just an overkill. You cannot apply IEC standards for pico hydro in a village. But the main part is maybe to keep electrical safety. That shouldn't be compromised at all, and not to kill the people in the village by not knowing electricity and the safety.
Thank you, Gerhard. I'm just hearing from Aisha that we are struggling to download Gerhard's presentation.
For local government. And as far as I know, NEPeD had some standards in Indonesia. Is already ongoing that the Indonesian standard will be implemented. Maybe Centano is also part of here. I see him is here. Maybe also can report a bit about the status of the Indonesian standard, national standard. Centano is the head of the association Hydro Bandung, and possibly he can say something about Centano. Yeah. Yeah. Oh, you're still mute, Centano.
Oh.
Oh, now.
Hello.
Now we hear you.
Hello. You.
Centano, would you like to give your thoughts?
Yes. But you.
I was wondering if you could follow on from the point that Gerhard was just making.
Yeah. We involved in Indonesian standard for hydropower, and we have a standard for 25 kilowatt minimal for people in the remote area. They use money from government. We make standard. They must be yeah. Sometimes people in the village say this is my turbine, but not turbine. They make only water wheel, and this standard is to make more the same perception what kind of turbine like this one. And now we develop standard for not only for micro hydro, but for mini hydro to 1 megawatt. For this larger size, we use standard from ICA. We translate, and we already adoption of pico hydro, Pelton, Francis, and tubular turbine.
Thank you, Sentanu. So Gerhard, unfortunately, we have not been able to get your pre-recorded presentation, and also because we have started the Q&A, we are now running out of time somewhat. Would you be able just to give us a brief version of your presentation, and perhaps then we can make the full presentation available at a later date?
Okay.
I think Aisha can share your slides, and perhaps we can move through them quickly.
Yeah, let me see. I can do that. Let me see the thing here. All. Let me try to share the screen. Oh, Mana.
I think Aisha is loading your presentation.
Oh. Is this my screen or your screen?
This is Aisha's screen. Yeah. So
okay.
If you tell her, then she can move through the slides.
Yeah. Okay. Then we do it that way. Huh?
If possible, we it may have to be an abridged version because we only have 7 minutes and we'll be automatically removed.
Actually, everything can be accelerated. Don't worry. Can we go back to the first one, maybe? First slide. Okay. Yeah. Okay. You asked me some kind of insights on technical standards for micro mini hydro to enhance the reliability. Next one. Next slide, please. Okay, everybody is aware that hydropower is a long-term investment and long-term technology. All over the world, there are 100,000 of sites running, many of them over 100 years. But having such a reliability, it also has some initial investment costs. Yeah. So I want to show one example in Indonesia. It's a 100-year-old power plant, which is running in Sumatra. Next, please. Good. Basically, we started, there are 3 units like you see in the picture. We started to rehabilitate one. And meanwhile, all the 3 units are rehabilitated. The civil engineering after 100 years was still in good condition. And I'm sure this power plant is now grid connected and can be operating another 100 years. Yeah. In the beginning, this power plant was supplying a gold mine, then a cement factory, then some villages, and then an ice factory, and now it's online to produce energy for the national grid. So that's what I call a long-term investment done by people 100 years ago, and we still benefit from it now. Next one. Okay, there are a number of international standards for the hydropower. Most of them, for our purpose, what we discuss here may be below 200 kilowatt or below 1 megawatt, are far too complex and made for mega big power plants in the megawatt or gigawatt area. So as mentioned, some countries have started already to make some national standards for the smaller output, as far as I know, Nepal and Indonesia. But one thing, we never should compromise on electrical safety because that can kill people. Next one. Okay, maybe here to show a bit that from pico to full-scale hydropower, we also have to adapt the standards we apply. So if it comes to supply a house, regular maintenance and so on wouldn't be a big problem. In a micro hydro, already villages involved, so the reliability must be bigger. In a mini hydro, villages, factories, mini grids are involved and have a lot of problems to if it's not technically sound produced. Next one. Good. Quality standards, of course, as you are aware, starts from the catchment to the transformer. And all the civil structures should be done properly and also professional. The electromechanical safety should have electromechanical equipment, should focus also that it's safe and long operating. Distribution like transformers and network should also be done very careful. If you're low voltage, it's maybe different than medium voltage. So you have to make the people aware of the danger of your distribution net as well. An operation and maintenance system, you also should be involved. So quality is not only the turbine or the generator or the ELC, it's a combination of all the elements of a hydropower plant. Next one, please. How to get reliability? It starts with a good study of hydrology and water availability. And as our friends before said, the catchment area is also extremely important to be protected so that the water is available in a good quality and not the floods and rubble and stones and so on are entering our civil structures. The civil structure should be properly planned, properly supervised, and possibly to check from an experienced engineer to avoid mistakes which are even in Indonesia, some megawatt sites, the forebay is gone, the powerhouse is flooded. Shouldn't happen at all. And all the elements need good workmanship and supervision. Electromechanical equipment should come from a professional and reliable supplier. This can be a village supplier if he's nearby to repair the things, so it doesn't mean everything must be completely perfect. And of course, operation and maintenance systems also should have trained operators, as we have heard already. There must be a proper maintenance system and schedule. And of course, one thing is also important, let me say, the awareness of breakdowns of the site. So people may be not aware that they waste a lot of money by not buying a spare part for $10 and available of spare parts and so on as well. Next one.
Gerhard, I'm just briefly going to interrupt you because I think that the session will automatically end in just 40 seconds.
Okay, good.
Hopefully we can pick up our discussion separately in breakout rooms. Yeah. But before we are kicked out, I just wanted to thank all of the presenters today and just emphasize that it's great to hear about these examples of established manufacturing centers and hear about approaches that are made to work alongside the community, where in all of the examples today, we hear about working with the local community. And we were just getting started on hearing about national standards.